Industrial Revolution, Part 2. At the beginning of the Industrial Revolution, transportation was almost the same as it had been during the Middle Ages. Land travel was by stagecoach and wagons over rough roads that were dusty in dry weather and muddy when it rained. Transportation by water was at the mercy of wind, which furnished the necessary power. Neither of these forms of transportation was adequate to meet the needs of a rapidly expanding industrial economy. The success of the Industrial Revolution depended upon being able to transport raw materials and finished goods over long distances. The demand for coal increased greatly with the Industrial Revolution, and delivering it to factories in small quantities by wagon was unacceptable. Waterways provided the only cheap and effective means of hauling coal and other heavy materials. Great Britain had many rivers that, when connected by canals, could be adapted to carrying freight. With canals, raw materials could be brought more cheaply to the factories, and finished products could be more easily carried away. One of the first English canals to be opened was the Bridgewater Canal, designed by James Brindley. The Bridgewater Canal connected coal mines at Worsley to the city of Manchester, 8 miles away. The canal was so successful that following its opening, the price of coal in Manchester was cut in half. The age of the canal was launched, and by the end of the 19th century, there were more than 6,000 miles of canals and navigable rivers in operation in Great Britain. Most of the early canals followed the contours of the land and wound around hills and through the quiet countryside. Later, to make canals as straight and short as possible, tunnels and aqueducts were constructed. Locks were installed to raise and lower boats from one level to another. A lock consists of a chamber with gates at each end. With the top gate closed, a boat heading upstream moves into the lock. The bottom gate is then closed, and a small opening in the upper gate, called a paddle, is opened, letting water into the lock. Water enters the lock, raising the enclosed boat until it reaches the water level of the canal above. The upper gates are then opened, and the boat moves out into the upper canal. The process is reversed to lower a boat from one level to another. Locks may be singular or many and be connected together when the elevation between two waterways is great. Other methods were devised for moving boats up and down hills. One such method was the inclined plane. With the help of rails and winding gear, boats could be carried up and down the slope from one canal to another. The Hay inclined plane at Blist's Hill in the Iron Bridge Gorge linked the tugboat canal of the Severn River to the Shropshire Canal 207 feet above. This change in elevation would have required 27 conventional locks. Opened in 1793, boats were floated onto wheel cradles, which carried them up and down the slope on iron rails. Winding machinery operated by a steam engine was used to pull the boats to the top of the inclined plane, where they were floated off their cradles into the canal above. A pair of 5 or 6 ton boats like this one could be raised or lowered in 3 1/2 minutes. This inclined plane was in use until 1894, more than 100 years after its initial opening. With the advent of the railway, the future of canals as a major source of transportation was doomed. By the 1830s, growth of the canals was halted, and they went into a steady decline, and were abandoned as a primary source of transportation about 100 years later. Railways did not appear until the second half of the Industrial Revolution, because their development depended upon advances made during the first part of the Industrial Revolution. Early railroads utilized iron rails and wheels that had been made by the Coal-Brookdale Company in the Iron Bridge Gorge. They carried coal and were pulled by horses, which were eventually replaced by the steam engine. The history of the steam engine closely parallels the revolution in industry. It was the greatest single technological innovation of the early Industrial Revolution, providing industry with a cheap and efficient source of power. Neither animals nor water could provide the power needed for the new factories. Without the development of the steam engine in the 1700s, modern industry would not have been possible. One steam engine could supply all the power needed for a single factory or do the work of more than 100 horses. And, unlike horses, these new iron engines did not need to rest. A steam engine operates by heating water in a boiler and changing it into steam. The steam expands, creating energy that can be used to push a piston back and forth. This back and forth motion can be used as a source of power. By attaching a crankshaft to the piston, the back and forth motion can be changed into rotary motion. A locomotive is a good example of the use of rotary motion. Rotary motion can also be used to supply power to stationary machines in factories, enabling them to do all types of work. In 1712, Thomas Newcomen invented a steam engine that was used for pumping water out of mines. It was called a beam engine because it had a horizontal beam that was balanced in the middle like a seesaw. A piston inside a cylinder was attached to one end of the beam. Steam forced the piston up, lowering the other end of the beam, which was attached to a pump. Cold water was then sprayed into the cylinder that forced the piston up by steam. The steam condensed, forming a vacuum, which sucked the piston down again. This in turn raised the other end of the beam, lifting water from the mine. Newcomen's steam engine was not efficient and turned only a small part of the energy it received into useful work. In 1769, James Watt patented an improved version of the steam engine. In 1781, he also discovered a way to adapt his steam engine to rotary motion. Watt's improvement of the steam engine made it practical for use in situations other than pumping water out of mines. It could now be used to run machines in factories. Early steam engines operated on low-pressure steam, which limited the amount of power they could produce. Richard Trevithick built the first high-pressure steam engine in 1800. Although it was never operated successfully because it was too heavy for the railways at that time, it did serve as the model for most later steam engines. Trevithick also built the first steam locomotive to run on rails in 1802 at the Coal-Brookdale Iron Works in Iron Bridge Gorge. Today this locomotive is on display at the Science Museum in London. In 1813, William Hedley built this steam locomotive known as Puffing Billy. It carried coal at the Wylam Coal Works for 49 years, and it could pull 9 laden wagons at 5 miles per hour. Now in London's Science Museum, it is the oldest surviving steam locomotive that was successfully operated during the Industrial Revolution. By 1815, steam engines were being operated at 200 pounds of steam pressure, creating even larger amounts of cheap, efficient power for industry. George Stephenson, known as the father of steam locomotion, built a steam locomotive in 1825 that could do the work of 40 teams of horses. His locomotive, named the Rocket, could pull a train at an average speed of 14 miles per hour. It was chosen as the engine for the railway that opened between Liverpool and Manchester in 1830. This was the first railway to employ only steam locomotives on its line. It was also the first railway to provide regular freight and passenger services, marking the true starting point of the railway age. In 1750, it took 11 days to travel by road from London to Edinburgh, Scotland. By rail in 1850, this same distance could be traveled in 16½ hours. Providers of transportation by water were quick to recognize the potential of the steam engine. It would not only provide them with a cheap source of power, but also provide them with a source of power more dependable than wind. By the mid-1800s, ships powered by steam were carrying raw materials and finished goods across the Atlantic Ocean. The USS Savannah was the first steamship to cross the Atlantic Ocean. Steam-powered engines cut many days off the time required to make the journey by wind-powered ships. The same revolution that created changes in industries also created changes in the lives of the people working in them. The shift from an agrarian to an industrial system brought with it numerous social problems. No longer was it possible for employers to have a close relationship with factory workers like they had with cottage workers. Employers drove the workers hard. Long hours were enforced with few periods of rest. In this textile mill, the workday began at 5:30 a.m. and ended some 13 hours later. The work week was 6 days. Wages were low, with women and children being paid less than men. People were indentured to work and had to sign an agreement such as this, which spelled out the number of years they would work. The document further ensured that the workers would be faithful and obey the lawful commands of the factory owners. In exchange for this, the apprentice was provided meat, drink, washing, lodging, and wearing apparel during the term of the contract. Children were employed in large numbers, often under dangerous conditions. It was not uncommon for children under the age of 10 to work 12 or more hours a day. They did everything from operating machines to providing water for other workers. It was considered too expensive to allow individual workers to go for water themselves. Unsanitary conditions for factory workers were common, and toilets were Spartan. Most people who left the farms to work in factories were ill-housed and crowded together. Many of those who worked in the Colebrookdale coal field during the 18th and 19th centuries lived in houses like this, which were known as squatter cottages. Squatters built their own cottages on common or wasteland, often with the approval of the lord of the manor, who would not charge them rent but could impose an annual fine for encroachment. This cottage, erected in about 1825, measured 20 feet by 12 feet. It consists of a bedroom and a living dining room and served as a home for 8 people. The cottage had a clay floor and was built on a site where slag from a nearby mill was dumped. Many times, squatter cottages were the beginning of settlements, as squatters built cottages side by side or connected them together by common walls. Without proper water or sewage facilities, unsanitary conditions existed. In many instances, this led to outbreaks of diseases and a decrease in worker productivity. In addition to these unhealthy conditions, air pollution was often a problem because of the many foundries and factories using coal for fuel. The working and living conditions of workers began to improve in the 19th century, and churches such as this one were provided for the mill workers. It was originally unlawful for workers to join a union, and those who did could be imprisoned. Strikes and riots began to occur to protest low wages and poor working conditions. Unemployed workers broke into factories and destroyed machines that they said were costing them jobs. Adam Smith's book, The Wealth of Nations, published in 1776, stressed the importance of labor in an economy. His writings about the role of the individual in production greatly influenced the political thinking of that time, which sowed the seeds for changes in the workplace. The law forbidding trade unions was repealed. Soon, other laws were passed regulating conditions in the factories. One mill owner, Robert Owen, improved the working and living conditions of his employees and provided education for all who wanted it. Although he provided good housing for workers, he took no chances of not being paid and deducted the rent from their wages. Owen's treatment of his workers became well known and served as a model for other businessmen. Slowly, life for all industrial workers began to improve. England tried to protect its early industrial discoveries so that it could reap the maximum benefits from these advances. Craft workers were prohibited by law from emigrating to other countries until 1820. The export of machinery was likewise prohibited until 1843. These efforts were unsuccessful, and the techniques of industrialization began spreading to other countries almost immediately after they were established in Great Britain. Belgium, France, and the United States all began to industrialize. Belgium concentrated primarily on textile making. Major textile centers were developed in the cities of Ghent and Liège and continue there today. Industrialization in France was delayed for many years after its initial beginning in the 1700s. The French Revolution and the Napoleonic Wars were responsible for this delay. Social and political problems in Germany held back industrialization in that country until the late 1800s, when several separate states were unified to form one government. The United States also contributed to the Industrial Revolution. By 1776, about one-third of Britain's ships were being built in America. In 1794, Eli Whitney's cotton gin made cotton growing profitable. His invention made American cotton cleaner and more abundant. This plentiful supply of cotton contributed to the rapid advances made in the early British textile industry. Francis Lowell established a textile mill in Waltham, Massachusetts in 1814. Lowell designed textile machinery superior to that in England and had the first factory in the world which combined all of the processes for manufacturing cotton cloth under one roof. The United States began to make significant contributions to the development of industry toward the end of the Industrial Revolution. American companies began supplying European markets with machinery for making tools. Mass production became commonplace, and American engineers became noted for their ability to design labor-saving machines that could be operated with unskilled labor. By the late 1800s, the United States became the largest competitive industrial nation in the world, a position it still holds today. The Industrial Revolution changed every aspect of everyday life and still provides the foundation and framework for modern civilization.